Last but not least, we have Mr. Kellen Schefter from Fisker. He works on a variety of public policy issues for Fisker Automotive, such as leveraging electric vehicle incentive programs implemented by federal, state, and local governments around the world. Prior to Fisker, Kellen was a Presidential Management Fellow at the U.S. Department of Energy Vehicle Technologies Program, which awards and manages grants for research and development projects at national labs, universities, and private industry. Kellen did his bachelor's and master's degrees in mechanical engineering at Stanford and also worked at Volkswagen. And in his spare time, he drives up to universities and nightclubs in his fancy Fisker. So, Kellen, take it away.
I'm glad you got my long bio. I wasn't sure what you were going to say there, but it's an honor to be here. Thanks for having me. I kind of want to accomplish two things. One is just kind of give everybody a background on what Fisker Automotive is all about. And then two, kind of talk about some of the policy drivers that are affecting electric vehicle adoption from our perspective. So there's the Karma. Hopefully you guys got a chance to see it. It is sitting out in the parking lot. If you haven't, I'll be around afterwards if you want to take a closer look. We are taking on the daunting task of simultaneously launching a new company, a new car, a new technology, and a new brand all at once. That is not an easy task, but we are doing it. So what is our formula for success? Well, from a product perspective, I really look at it as three things. One, make the car sexy. And I say that kind of jokingly, but I'm actually pretty serious. We forget in the discussion of incentives and cost-based analysis that cars are often a very emotional purchase. So if we can make electric cars cool, look good, fast, luxurious, they will sell themselves on those traits alone, and the EV aspect of it can almost be an afterthought. Two, start at the top of the market. This is not a car that absolutely everyone can afford. We acknowledge that. It is at the upper end of the luxury sport sedan spectrum. But we actually chose that deliberately because it is easier to introduce new technologies at that price point. You see that in a lot of different technologies. And then as we learn more, as they get out on the road, as people understand them better, we can move costs down over time and eventually get the whole market. So that's the second piece. Third, make it an extended range electric vehicle. Now, there's a lot of different ways you could approach that. Pure EVs, blended, hybrid. We're calling it an electric vehicle with extended range. So it will rely purely on battery power alone until that battery is depleted, and only then will the engine come on. The rear motors are powered exclusively by the battery. The engine, when you want to go further than the battery will allow, only generates electricity to go to those motors. So there is no mechanical link from the engine to the rear wheels. And again, we do that because at this price point for this buyer, luxury really means freedom. So we can argue about how much of a barrier range anxiety really is for drivers, but for our customer, we don't want them to be concerned about, how will I get to Palm Springs if I can't charge along the way? So that's sort of what we're going after, and that's sort of how I would characterize our product. Again, this is sort of characterizing what I'm calling sort of the top-down approach, where we are starting at the upper end of the market. And I've sort of drawn a separate column here for EV extended range, which is separate from a plug-in hybrid, although you could argue that those kind of overlap. And what you see at the upper end, everybody's doing hybrids now. BMW has a hybrid, Porsche has a hybrid. But at the upper end of EVs and plug-in hybrids or extended vehicle or electric vehicle extended range, it's really only us and Tesla. Tesla's gone the pure battery route. We're going the plug-in hybrid or extended range route. And then what we both intend to do is sort of bring costs down over time with new product. And you can see in contrast, coming from the bottom-up approach, I guess you could say, would be Chevrolet with the Volt and Nissan with the Leaf, really trying to go for mainstream buyers. And there's two different approaches, and there isn't necessarily a right way, but this is the kind of the path we have chosen. So what does that look like? Well, this is the car that we revealed in New York last week. We're calling it the Atlantic. For a long time, it had been known as the Project Nina. And it's still the platform, we're still calling it internally Nina, but this vehicle is called the Atlantic. It will be cheaper. We're not talking about price yet, but if you think about the Karma maybe competes with an Audi A8, BMW 7 Series, this would be more like an Audi A5, BMW 3.5 Series, that sort of range. And it looks pretty good too, so we're happy about that. Okay, so now I'll shift to the policy side a little bit. we're clearly in a time now where electric vehicles are getting the best push they've probably ever had. There are a lot of drivers for that. There are economic drivers. We want to create jobs in the U.S. That's a big piece recently. There are environmental drivers. We acknowledge that EVs have the potential to drastically reduce carbon emissions from personal mobility. And there's also, national security, energy security drivers. And in this State of the Union, in 2011, you can see Barack Obama, President Obama, is pushing this goal of 1 million electric vehicles by 2015. We can argue about whether that will succeed, but it is good to have that goal. And then we can move to the discussion of, okay, if that's your goal, if as a society we decide we want to move toward electric drivetrains, how do we do that? So here's how I've sort of broken up the various policy tools that are out there. You can incentivize or disincentivize automakers or customers. And there's obviously more than this, but this is sort of how I look at it. To incentivize automakers, you have the Advanced Technology Vehicle Manufacturing Loan Program, Loan Guarantee Program. We were a recipient of one of those loans, as was Tesla, so was Nissan and Ford. So that was basically saying if you have a plan for U.S. manufacturing for clean vehicles, we will provide low-interest financing. So that's an incentive for automakers. There's also R&D funding. When I worked at Department of Energy, we would provide grants for research. Who will help us bring down the cost of a battery? Who will help us improve the efficiency of an engine? We will do a cost share with you, and that's an incentive for automakers. Disincentives, you have CAFE, Corporate Average Fuel Economy Standards, and EPA greenhouse gas standards. They're a harmonized regulation. They're new. They basically say your whole fleet has to meet a certain fuel economy level and a certain greenhouse gas emissions level. It's a disincentive because if you don't meet that, you get fined or you can't sell cars anymore. So that's definitely a disincentive for automakers. There's also the ZEV program in California in particular, although it's very influential, and that is a technology forcing regulation. If you want to sell cars in California, you have to sell a certain amount of ZEVs, zero-emission vehicles. So that's another disincentive for automakers, because if they don't meet that, then they get fined. For consumers, we don't really have a disincentive. We have incentives. So we have the $7,500 federal tax credit. That's huge, and we qualify for that. And there's a sort of smorgasbord of state incentives out there, and one of my jobs is to kind of track those. We can discuss whether you would think you would need a disincentive. In Europe, some European countries, they have a bonus mallet system. So you would get some equivalent to our tax credit for buying a clean car. You'd also get dinged for buying a dirty car. We don't have that in the U.S., except the natural disincentive that it'll cost you more at the pump. So here's sort of a quick look at the various state incentives that are out there. There's a lot. There's more than this, but I've sort of selected ones that we explicitly qualify for. The range is really funny. I mean, Arizona, you're not an alternative fuel vehicle unless you're exclusively powered by the alternative fuel. So we have a gas tank. We're not an alternative fuel vehicle. However, in Maryland, they welcome us to their HOV lanes because their criteria is if you qualify for the tax credit, then you can go on their HOV lanes. So it's different in every state. The best one probably is West Virginia. They will match the federal tax credit. They will give you up to $10,000 for a charger, probably because their economy is largely dependent on coal-fired power plants, and they want to sell more electricity. So you wouldn't expect West Virginia to have the best one, but they do. Here's the EPA greenhouse gas standard. Now, this is a little complicated graph. Basically what you do is it's footprint-based. So you look at the footprint of your vehicle, you go along the x-axis there, and then you move up to the line corresponding to that year, and that's the CO2 level you have to hit. Now, an automaker will take that chart, plot every car they have on there, do a sales-weighted average, and they'll see, okay, you end up with one number. This is the CO2 number that our fleet has to hit for the year. If you end up hitting that target, you're good. If you don't, you accrue debits or deficits. If you do better, you accrue credits. So there's actually a cap-and-trade system in the auto industry. And we would all love a comprehensive carbon cap-and-trade system for the whole economy. We don't have that. And I hesitate to even point out we have one in the auto industry because it's not politically popular. But there is a cap-and-trade system essentially in the U.S. auto industry. Now, there are incentives built in here for electric vehicles. So right now, EPA has decided through 2021, if you build an electric vehicle, you don't have to worry about upstream emissions. That's a big benefit because upstream emissions for electric car are the emissions. So that's an incentive. However, for a company like GM or Nissan, if they benefit from that, that means they can probably sell more Titans or Ford F-150s or whatever, right? So they all keep their credits. For a company like Fisker or Tesla, the opportunity there is that since we sell exclusively vehicles that will massively over-comply with this rule, we'll generate credits. And so maybe we can get revenue that way. We don't know yet. That's a brand new market. It's closed. Most people don't know about this, but it is something that there might be an incentive built in there that we would look to take advantage of. Now, if you look at California's ZEV program, like I said, this is a technology forcing rule. So this is sort of their expected scenario. Basically, they're expecting by 2025, 15% of new vehicles in California will be one of these ZEV categories. And that's, like I said, a technology forcing piece. So rather than say, okay, your whole fleet has to meet a fuel economy average or a CO2 average, they say a certain percentage of the vehicles you sell have to be one of these vehicles. And so we are looking, again, there's a credit system within there where you could, a company like ours or Tesla could take advantage of selling credits to other companies. And so the last piece I'll kind of end with is our fuel economy label. Now, we don't think too much about that being an incentive or a disincentive, but communication is actually a really big piece of how these vehicles are marketed, how people perceive them. This is our fuel economy label. What EPA has decided to do is everyone knows miles per gallon so well, they don't really care if it applies to the car you're talking about, but let's coach everything in terms of miles per gallon. So we have essentially two powertrains. You can run off the battery or you can have the gas engine supply power to the battery. When you're running in electric-only mode, you are getting the energy equivalent of 54 miles per gallon. You're not actually burning any gasoline when you're in electric mode, but they took a lower heating value of gasoline, determined how much energy that is, converted it to battery, electric power, and they said, okay, that's equivalent to 54 miles per gallon when you're in electric mode. If you're in range extended mode, you're only getting 20 miles per gallon. Now, that's true, but we're not a huge fan of that presentation in particular because if you use any electric range at all within a given trip, you won't experience 20 miles per gallon. And so while this does tell you what the relative efficiency is in each of the two major operating modes, it doesn't tell you anything about how you'll use the car. And so what I've done here is, okay, let's say you take a 40-mile trip. We have an EPA rated range of 33 miles. That first 33 miles, let's say, will be electric powered. You will have burned no gasoline, but you'll have consumed some amount of electricity. And then you go another 7 miles gasoline powered. Well, let's look at the MPG, the miles per gallon for gasoline consumed. That's actually 114 miles per gallon because you drove 40 miles and consumed 0.35 gallons of gas. If you're concerned about total energy use, then you're concerned about MPGE. And again, you would sort of weight the two numbers on the label and you end up with 42 MPGE. So now, we would love to see something like 114 miles per gallon in our EPA label because that would stand out more to people. Instead, they see 54 and 20, and so that's a communication challenge that we have. For instance, in Europe, they see a single CO2 rating of 51 gram per kilometer. The equivalent in the US would be about 107 miles per gallon. So different regulatory agencies have different approaches. We would argue it would behoove the agencies to just incentivize it a little bit, to make it to bet on the consumer that they will use the electric range. But instead, this is the approach they've taken. And so that's one of the communication challenges that we have, that it will really depend more so than ever on how you use these vehicles. So I'll stop there, and then any of those topics that you guys have, I'd be happy to take questions on.